Events drive the heartbeat of user interactions, system responses, and program behavior. By the end of this video, we have unveiled the secrets of event handling in Java, empowering you to create dynamic and responsive applications. And before further ado, let's just look at what is event handling. Basically, event handling refers to the mechanism by which an application responds to events or actions generated by the user, the system, or other sources. Just going to have a very simple slide here. Let's first of all take a look at this. So there are two types of events, and we have what we call foreground events, and these normally occur in the user interface or the graphical user interface, and they happen when you select a menu item, or when you click, or when you scroll. That is what we call a foreground event. The second category of events are background events, and these events do not require the user interactions to run. For example, task completion. Let's say, for example, you have a database somewhere and you want to run another function once a user has been added to the database. You can have an on user added to the database event, and that event will run after a successful event where a user has been added to the same database. So even though there has been a user interaction at the beginning, in the end of it, the user is not required to fire up that other event. Then we have what we call the event delegation model, or the Java delegation event model. This is the mechanism by which Java uses to handle events. So what is this? It contains two items, and one of these is the sources. And what are the sources? So we have the sources and the listeners, but let's first of all explore what are the sources. So the sources are just the graphical user interface items, what the user interacts with in your application. So we have buttons, we have lists, we have menus, we have menu items, we have checkboxes, etc. So the sources generate the events, okay? Then we have the listeners, and the listeners are used for handling the events generated from the source. All right, and it's important to know that each of the listeners available in Java represent interfaces that are responsible for handling events. So these interfaces, they are supposed to be implemented whenever necessary, depending on the use case. Okay, and I've given you examples of interfaces here. For example, we have for the action event, we have the action listener. For the focus event, we have the focus listener. For the key event, we have the key listener. For the window event, we have the window listener. Okay, all right, I hope up there we are together. It's very important to understand that we have what we call the delegation event model, the mechanism by which Java uses to implement event handling, and it contains two items. So it has the sources generate the events, and it has the listeners. The listeners perform some action once they register a certain event accordingly. So let's look at registering the source with the listener. All right, and I've just explained that for event handling to work, we need to register the source with its correct listener, and the basic syntax is add type listener, where the type in this case represents the event type. Okay, so once the event has been generated from the source, we need to register it to the correct listener. Okay, so let's just look at a few examples. For example, we have for the key event, the add key listener will be used to register that event or the source to the listener. Okay, for action event, the add action event listener is used to register the source to the listener. That one is very important to note. So after this, let's look at what's next here. So you have three approaches of handling events in Java, and one of them is within a class, and I've explained here is that the event is handled from within the same class, right? So we see that in code show tree. Then we have from other class. Here the event handling is implemented in a different class. So in this case we normally have two classes. I'll explain this further in the code as well. Then the third way is it's implemented anonymously, and in this case the source is assigned the action listener using an anonymous action event class instance. Okay, so let's just take a look at this and see how it works. So right now I'm going to just escape this and I'm going to go to the code, and I'm on IntelliJ here. So don't just look at the first instance where we implement the event listener from within the same class. Okay, here we're implementing it from within the same class. So I'm going first of all to just minimize that, or I'm just going to increase this font size just a bit for you to be able to see. So in this case we just have a very simple application, and the structure of this application is we just have a window, and then we have a text, and we have a button. Okay, and obviously we have set the bounds or the positioning of the text field and the button in the window. Then we are just adding the action event listener to the button. So the button in this case is the source, right? And this is the listener. Okay, so this is what we call registering the source and the listener. And then we have to pass in some context. In this case we are passing in the this to refer this action listener to the instance of this class. And it's important to note that we are implementing the action listener interface. Okay, and that's why we are able to override its method here and implement it in our own way. Okay, you just say what should happen when an event has occurred, right? What should happen? But basically here we are handling all events. Okay, we are not looking at hover, we are not looking at other events. We are just looking at any event. We are not specific about the kind of event that we want to handle here. So it's just an action event. Any action that happens within that source, then we are going to do this. Okay, we are going to run this piece of code, and what this piece of code is doing is just setting the text field value to handle from within. Okay, so it's very, very simple. We're just extending the frame, and this will be the structure of all the three applications. So we basically have a class, and then to extend the frame, Java frame, so that it can give us that nice window, and then to implement the necessary interface depending on the event that we are trying to capture. Okay, so then once we have implemented that, of course we have the main method, and this method is just returning a new instance of the handle from the within class, which is the same, which is this class. So once we run this now, so I'm going to run this, and I have it here. Let me bring it into view. So we have this. Okay, so this is what is supposed to happen once we click on this button. We are supposed to see the text, some text inside here that says handled from within. Okay, so I'm going to click that, and we have handled from within. All right, so very simple, very basic. Right, that's very simple. So let's check how it's handled from another class, and then we'll be able to finally look at how it's handled anonymously. So let's look at this handled from within the same class. So again, we have the same structure of the application. We have a class handled from another class, and it is extending frame. But notice that in this case, we are not implementing any interfaces here, right? That is because the interface will be implemented in the other class, and then it will be called inside this class, and the context passed accordingly. Okay, so let's look at, so basically we have the same thing, the text field, then we have a constructor, and then inside the constructor we are defining we are initializing the text field, then we are setting its position, and then we are creating a new button here and setting its position as well. But now here it's different because we have this other class we are calling other, and we are creating an instance of that class, and then we are assigning it. So this class takes an argument, and that argument is the handle from within class, an object of the handle from within class. So let's just look at this class and see what is happening. So if you look at this class, this is the other class. Okay, so this class is very simple. It's just a class that implements the interface action listener. So instead of implementing the interface in the handle from in the main class, we are handling it elsewhere. Okay, we are implementing that elsewhere, and then we just call that functionality here by creating an instance of that class. So this class is very simple. It just takes, in the constructor, it takes an object of the handle from another class, and then what it does now, once it binds that instance to this variable here, then we are able to access items from that class, okay, from the handle from another class in this case. I just need to clarify that so that you're able to understand better. So it's simple. Once we have implemented the constructor here, then this variable is able to give us access to everything that is found in this class, okay, using this object, right? And so this is just a basic OOP in Java. Okay, so then now, because we want to bring this functionality of this class, especially the context, which will now give us ability to access this action performed event here, the override of this method here. So we just create a new class, or a new instance of that class, and because it is taking an object of handled from another class, which is this class, we just pass this, okay, to tell this, and this tells Java that the object that we want to refer to is actually within this class. It's actually within the containing class from where this object has been created. So after that, we add that, we set the buttons action listener using what we have created. And once we do this, this tells this button that go to this object and take the implementation that has been done there for the action listener interface. Okay, and so that is why it's able to find this. And so once we run this, we should be able to see handled from another class. Okay, so I'm going to run that. So it's running now. We just put the window into view, and so once we click this button, we should be able to see handled from another class, and that is it, handled from another class. Okay, so let's go and see how we can handle the same thing using an anonymous class, right? And so I still have the same project structure. just have a class, it's the extends frame. Notice that even now we are not implementing any interfaces here. So we have a constructor where we are defining everything the same way. Then, but now on the button, we are on the add action event listener. Now this is why we are defining or creating a new anonymous class, okay, accordingly. And here we need to create an instance of the anonymous instance of the new action listener, which will let us implement the necessary method, which is this action performed within this block without necessarily having to implement any interfaces here, right? And so once we just run this, we should be able to see that. Okay, just a minute, let me see. Okay, let me run this again. Not being able to access it accordingly, but let me run it and see. Okay, now this is running. So you can see here, so once we click here, we should be able to see handled anonymously, and that's it. So I hope you have understood, and I hope this video is helpful for you. And if that is the case, kindly support my efforts by liking and subscribing to the channel. Thank you.